And welcome back, Mindsetters. Hope you had a nice little break. Did whatever you had to do. You went to the bathroom, or you went to answer the phone, or your mom was all calling you for something. Now you need to make sure that you're paying attention and you're ready. And if you're like Ashworth and you're just loving the show, thanks for letting us know. Make sure you post on the page. But by the way, Mr. Aslam, we had a question come in here from Sibusiso. She wanted to find out, well, he wanted to find out. I can't tell because I think he's in the picture with his girlfriend. Not sure. But anyway, how does fungi and athlete's foot relate?
Fungi and athlete's
Athlete's
foot.
foot, yeah.
Great question. Sibusiso.
Sibusiso.
Great question.
Siboniso. sorry.
Siboniso, good question. What is athlete's feet? Firstly, somebody like Caster Semenya that can run very fast, got athlete's feet.
Not quite.
Not quite. No, guys, that's not what athlete's feet is. If you have athlete's feet, you're not going to run any faster. You'll scratch a lot more, you'll itch a little more, yes, but not running any faster. Athlete's foot is when fungi grow in areas between your toes especially. By the way, that fungal infection can actually spread throughout the body. If not treated properly, it can actually, I've seen people with the fungal growth on their hands and the rest on the body as such.
Wow.
I've seen that happening. So what happens here is, first of all, now you've got to go back to your grade 11. Learn about fungus a little bit. Characteristics of fungus. What do they like, fungus? They like damp, dark, moist areas. Because you see, fungus don't have chlorophyll, so they don't need light. And they need moisture and a warm temperature to make it favorable for them. And as long as that temperature is favorable and the rest of it is favorable, they reproduce. And where's our bad habit coming from? We wash our feet, we don't wipe them, we put the socks straight over. So we've already created a warm, moist, dark environment. So what happens, the fungus, if they're in the air, the spores of the fungus are in the air, they would start infecting you on your toes. And because they are causing harm to you, they're getting food, etc. from you. So what relation is this?
Parasitic.
Parasitism again. So even fungi on your feet or athlete's foot itself is an example of parasitism. Way to cure that, obviously there are creams and sprays and powder, etc. But more importantly than that, make sure that your feet are kept dry as far as possible, that after you shower, etc., you make sure you give yourself enough time for your feet to dry up properly before you wear your socks. And if you have athlete's feet, best to do is to stay without socks for a while. Obviously, you can't go to work with sandals and things like that. But when you're at home, try to keep barefoot or with sandals so that you are not covering the area. Expose them to sunlight, unfavorable conditions, and in that way, you kill them. Okay? But you have medication as well for it. So, athlete's foot, fungus infects humans, and this is an example of parasitism. Another example of parasitism. Good. That takes us now to the questions again. We're still with the same passage, very big passage, but you would have had to read it. The question now says, by referring to the passage, give the names of organisms involved in intraspecific. We've already explained what intraspecific competition was just before this, within the same species. Can we say here that the lions and cheetahs and impalas was intraspecific competition? No. But we can say that there was intraspecific competition among the lions themselves or among the cheetahs themselves. But in this passage, there's no real evidence that the lions were competing because they do not talk about the populations of the lions, they do not talk about the population of the cheetahs. But they do talk about the impala population that was at 8,000, and then it went up high, and then it went down to 4,000, and it was going down further. And here we have only 20,000 impalas, the carrying capacity of that. So obviously, among the impala, there was intra-specific competition. That's the main one. However, if we argue, we could say that obviously among the lions, if they competed among themselves, there was also, and among the cheetahs as well, even among the plants, the vegetation in this case. But they're not telling you what vegetation, so you can't really talk because it must be of the same species, not just vegetation itself. So the most correct answer would be impala here, because you can see this competition because the population was at a certain level and is dwindling. Our next question is inter-specific competition. And obviously that's easy because we're having lions and cheetahs. They will both compete for the impala. They both want to eat the impala. So that's between two different species. They are competing to eat the impala. So the lions and the cheetahs would be that answer there, lions and cheetahs. Now you must be careful here. We're talking about between the lions and the cheetahs. Not among the lions themselves and the cheetahs on their own, not separately. But the two together are competing for one resource that is inter-specific competition. Moving on with this one here. Why did the impala population continue to decline after 80% had died during the winter? This question here, now you need a little bit of population dynamic background. Obviously, you can see what's happening here. First of all, that there were 80,000 of them. And when there were 80,000, they ate lots of the grass and what have you, the trees, etc. They ate it up. So if there was so much of food available, and this 80,000 ate so much of food up, then obviously the amount of food available now is less. So the carrying capacity of this environment has decreased. That is why, that means at that level, at 80, after the 80%, they were still higher than the carrying capacity. Therefore, it had to come below the carrying capacity. And we'll go more into carrying capacity and the rest of it a little later or in other lessons. We're going to ask what is carrying capacity, so let's explain it now first of all. Carrying capacity is the maximum number of individuals that a particular habitat can sustain. And it's not a blanket thing, it's talking of a species. In other words, how many impalas in this case here? What is the carrying capacity of this environment for impala? What is the carrying capacity of this environment for grass, for buck, for whatever? So that's what carrying capacity means. In a classroom situation, let's say for example, you have 30 desks in a classroom and chairs. Then obviously the carrying capacity of that classroom, that environment, if that was an environment out there, it was an ecosystem, would be 30. Any one more coming there would be bad because it's already full. If anybody leaves, it's not too bad because it's full, so it's not going to get too empty. On the other hand, if the class was only 5, and if some had to leave, it's bad because now this class is going to be like almost empty, or the teacher is going to have one child to teach. No good. So we'll talk about carrying capacity and the rest when you look at population ecology as well. And population, and this is nothing new, we've spoken about population in evolution, so let's talk about it again. Population is a group of organisms of the same species occupying a specific habitat at a specific time, and they must be able to interbreed. Now, I sometimes feel that this interbreed here should not be mentioned, but in exams you have to put it there, because when you say species, what is the definition of a species? It's a group of organisms that have similar characteristics that can interbreed. So obviously when we say they're of the same species, they must be able to interbreed. But you add it there. Okay? And this one here deals with predator-prey. So remember I told you, as we go forward, we'll get the other issues that we haven't covered in the content itself. So let's look at this one here. It's telling you relationship between population of jackals and rabbits. By now you should know that the rabbit is the prey and the jackal is the predator. You are at that age where you should know that. Population size, look at the graph again. It has a heading with two variables, the population of the jackals and the population of the rabbits. Over time, actually, it should say over time. And here they give you the years. It's got a heading. It's got frequencies there. Here you've got frequencies here. You notice the intervals, 100, 200, 300, 400. I'm just pointing this out because you need to know this when you're drawing graphs. Okay, so you can see what's happening here. There's the rabbit population there, the solid line there. And here, this one here with the circles is the jackals. You'll notice in this particular graph that the population of the jackals are generally, on average, lower than that of the rabbits. This is important. There must always be more food than there are organisms eating the food. So in a graph, in another graph, if they do not tell you which one is a rabbit, which one is a jackal, which is a predator, which is a prey, this is the first thing you look at. Number one, overall, on average, which one has a bigger population? Which one reaches a higher peak? That will be the prey. The one that reaches the lower peak would be the predator. The second thing you must look at in a graph, which one increases first? And if you look at this one here, you see that when this one increases, when that is increasing, then that starts increasing slowly, as you can see there. It starts increasing. The minute this one starts increasing, what happens to this one? It starts decreasing. Starts coming down. Why? Because the predators are getting more and they're going to eat more of the prey. So this is called predation pressure. The predation pressure increases and therefore they eat more of the prey and therefore the prey population starts decreasing. Now what does this mean? Logic. Less food for the predators. If there's less food for the predators, they must either move to another environment or stay there and die. So what happens to them? As the prey population comes down, then you'll see a little bit later, the predator population starts coming down again. And as that comes down, the prey population starts increasing. Why? Because the pressure on the prey has decreased. There's less organisms eating them. So predation pressure has decreasing. We say that the predator and prey relationship is an oscillating, like waves. When one goes up, then the other one also goes up. When one goes down, the other one also comes down, and so on. It's an oscillating relationship. And at the same time, it's nature's way of keeping check both population, that we don't have too much of prey and we don't have too much of predator. Both of these regulate each other. Important to note that. Here they want to know, first of all, what interaction, obviously this is a multiple choice, but I've discussed it, it's predation. The next one says, what effect does a decrease in the number of jackals have on the rabbit population? Jackals are the predator. If we decrease the jackals, what's going to happen to the rabbit population? Do they decrease? No. Is eliminated from the habitat after a long period of time? No. Rabbit population increases, maybe. Both the rabbit population and the jackal are eliminated from the habitat? No. So obviously our correct answer is C. Another way to see how we can eliminate and get to the right answer. We could ask, this question could not only be a multiple choice, we can ask many other questions here. What would happen if this happens to that one, and so on, and so on, and so on. What is the population of the rabbits at this particular year? You go up there, you look at it there, you go across, you read it off the graph, you give a figure. So those are the type of questions that we can get here. And I think we have one last question here that we can look at today. And this is also dealing with our second part of community structures, and that is this story about competition. First of all, competition is when organisms compete or fight for limited resources. Interspecific, we've spoken about, intraspecific. Now let's look at this one here. They say, look at these diagrams, A, B, and C. They want to know what is each one of this. They go back, they say, name the following, the community interaction represented in A, and I want to look at this one especially. Look at this one here. Many learners, this came from last year's paper, by the way. Many learners, the minute they saw a giraffe, they say Lamarck. This has got nothing to do with evolution, guys. This is environment. Now, here what you are seeing, you're seeing a tall organism, a slightly shorter organism, and an even shorter organisms. And what's happening is they have different eating areas. And because they have different eating areas, they can coexist. And this is known as a resource partitioning. And what this means actually is that different organisms can coexist in the same environment as long as they have different niches. The niches is the living space of that organism where it feeds. So look at a giraffe. It's eating on the leaves. So these guys don't bother it. And this guy is eating here in the middle. This guy here doesn't bother him. So they do not compete with each other. They can live together. You know, if you take a brother and a sister in the house, maybe they can coexist. But put two sisters in the same room, all hell breaks loose, right? Because they have the same requirements. The brother and the sister may have different requirements. The same thing happening. These have different requirements, and therefore they can coexist in this environment. This one here, you can see they're fighting for something. This is intra-specific competition. It's the same species, intra-specific competition. And guys, that's all we have time for today. I hand over to Ty.
Okay, so on that note, thank you so much, Mr. Aslam. That was a lot of information, but a lot of awesome information. And if you guys had just as much fun as we did, make sure that you post. Just say thank you. We enjoyed the show. And Mindsetters, I cannot stress enough, always just feel free to talk on the page, talk to each other, let each other know where you guys are at. And again, if you do not post, whether you're lost somewhere, if you need help, we can't help you. So make sure if you're lost anywhere, make sure you post and talk to us. But on that note, this is where me as Ty, I say cheers, and we'll see you next time.